Hey, fellow mathematicians, welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental mathematical relationships. That mathematics class can be less like it has been for so many of us and more like mathematicians working together. We answer the question, if algorithms are not your end goal, then what is?
Yeah. So we've seen a lot of different ideas out there about how to learn fractions. And 2 weeks ago, we started a series and we talked about 5 interpretations of rational number. And last week, we talked about half with young learners. We believe that the best way for kids to gain intuition or to get a feel for fractions is to gain experience about them.
Absolutely. So, Kim, we're going to exemplify this idea today by an experience that you had with your sons. You have 2 sons.
Yep.
Tell us about that experience. Go.
Okay, so a couple years ago, it was probably 5 years now.
Wait, a couple? 5?
Okay, 5 years. That's probably the word that I say incorrectly all the time. Couple is probably 2. Anywho, I just found this video and it was precious because they were 5 years younger and I just watched it again. But here's the story. So I had these little bundt cakes, these little kind of like buntinis in our freezer. And there was a chocolate one and a vanilla one. And so I wanted to pull them out and I wanted to share them among Luke and Cooper and myself. And so I pulled them out and I called Luke over and I said, hey, Luke, I've got these 2 bundt cakes. How much would we each get?
Only you would do this, by the way. But the more of us should. More of us should think about this. I don't know that I ever said how much, like we just eyeball. Anyway, so super. You're better than me. Keep going.
So he had just turned 8. It was the summer and he had just turned 8 like the week before. And right away he said 2/3. And I said, how do you know that we're each going to get 2/3? And so we dove into his thinking and he was thinking about splitting each of those cake into thirds. So the chocolate one into 1/3, 1/3, 1/3, and the vanilla one into 1/3, 1/3, 1/3, and dealing out 1/3 of the chocolate to each of us and 1/3 of the vanilla to each of us, right? That makes sense. And it was a fine splitting into unit fraction strategy.
Okay, I have to pause you for a second. I actually had to think about that. So if they're in thirds, there's 2 of them and they're in thirds. I get 1/3 of chocolate and I get 1/3 of vanilla. You get 1/3 of chocolate, you get 1/3 of vanilla, and the other kid gets 1/3 of chocolate. Okay, and then they're all gone. Okay, cool. Yep, that works. All right.
But then he said, Mom, I only like the chocolate one.
A kid after my own heart.
Right. Mom, I only like the chocolate one and you can't have the chocolate one. So that's going to be a problem. That's like problematic. And it was so fantastic because then it was a great problem for us to have, right? It made us like think a little bit further. And it led him to try to figure out how we could fair share the cakes so that we'd each get 2/3, but also take the flavors into consideration. And frankly, what he wasn't thinking about at that time was let's just trade. Like it was a new scenario. He went back to the idea that there's these 2 whole bundt cakes and I want to cut them so that we each get a fair share. And honestly, in this video that I watched, when he was 8, he tried to give some away. He was like, let's just give some to Dad. And he tried to say that he didn't need as much.
Wait. Like he could just give some to Dad and then it was easier to share them fairly?
Yeah.
Okay.
It was like a new problem for him, right? It was like a new thing to solve. And he tried to say, well, I don't need as much. So like, if you give me all chocolate, maybe I'll take a less portion. And eventually he did settle on him getting 2/3 chocolate, me getting 2/3 vanilla, and Cooper getting 1/3 of each.
Nice.
So he kind of worked through that. And interestingly was that he said that wasn't equal for each of it until he considered it again. At first he said, I'm not really sure if that's equal. And I had him talk through what he had just said. 2/3 chocolate for you, for me, 2/3 vanilla for you, Mom, and 1/3 of each flavor for Cooper. And it was such an interesting conversation. And then he was like, can I be done?
And I just want to point out, part of what is so noteworthy about this story is that you listeners, I don't know if you caught it, but Kim was like, I mean, obviously he could have just traded but for him, it was a new problem and everything.
Yeah.
So in the moment you were clear, dude, just trade and we're good. But you let him do the considering. You
Yeah.
let him do the grappling. This is what we mean by productive struggle. He's
Yeah.
interested in it. She can go with it. Even if you didn't sort of know the outcome, it would be worth just kind of letting everybody, the system, sort of grapple with the question. Nicely done.
And he
Okay, but you
wanted
have
bundt cake, right? He was motivated. So
all right, you have 2 kids. So what was Cooper doing through all
yeah,
this?
so Cooper, Cooper was hanging out because he wants bundt cake. And when Luke said, "Okay, I'm good."
Well, and to be clear, Cooper's younger, so let's just be
Well,
clear on
yes.
that.
So Cooper had just turned 5. It was like, they have really close birthdays. He had just turned 5, like 2 days before or something. And Luke walked away, and it was super cute and super fun for me because he jumped in the conversation and he said, "I have an idea." And when Luke walked away, Cooper jumped up on the counter and he talked about how to split those 2 bundt cakes if their dad had been home, if my husband was there. And it was ideal because we talked about 2 cakes being 4 halves. He said, "You can cut this one in half and you can cut this one in half, and we each get 1 half." And I said, "And how many halves will we have?" And he said, 4 halves. And we got to talk about 4 halves being 2 wholes. And then we got to talk about whether or not he would get more bundt cake if there were the 3 of us there, or if he would get more bundt cake if their dad was home and there were 4 of us there.
Oh, wonderful, wonderful, wonderful.
Yeah.
Yeah, all the vocabulary, all the things. That is so cool. But Kim, you in that instance, that time, you had time with your kids. It was a real experience. You actually had 2 bundt cakes
Yeah.
to share with 3 people. We can't do that in class, right?
Well, actually, right, and probably where I got some inspiration was that one of our favorite rich tasks is one that we use and tweak based on Kathy Fosnot's sub sandwich problem. And
Mhm.
you and I have done this a lot with kids of varying ages. I mean, a lot.
Yeah, a
And
lot.
what's super cool is that we get to have different conversations, different congresses with different outcomes based on the goal for that group. So let's tell a little bit. So the sub sandwich problem.
Yeah, and so maybe we'll just mention that this is from Kathy Fosnot's Field Trips and Fundraisers, and we'll put the link to that in the show notes. Like you said, we've tweaked it a little bit. Go ahead and tell us the problem.
Okay, so the problem is that there are this class of kids are going on a field trip, and the teacher has organized these parent volunteers, and she's going to send a group of students off to one location in the city, and a different group of kids with different numbers off to a different location in the city. And for lunch, rather than the kids bringing their own lunch, they've organized these long sub sandwiches to share among the group. So there's one group has 8 kids in it, and they're sharing 7 subs. And another group has 5 kids and they're sharing 4 subs. Then there's another group with 5 kids and they're sharing 3 subs. And then there's a last group that has 4 kids and they're sharing 3 subs. And so the story, the context is you've got these kids, they're sharing the subs, and they want to know, was it fair?
And to be clear, subs or sub sandwiches are sort of those big long sandwiches. I know you
Mhm.
said that, but just because we're colloquial, just cutting it off, cutting and calling them subs. So they're just these big sandwiches that are too big.
Right.
So y'all, you might want to write those numbers down because we're gonna actually dive in and do a lot of work. You might want to think about, was the situation fair? Did each kid get the same amount of sandwich? And think about that. If you've done this problem before, just keep listening. But if you haven't done it, you might want to think about how much of a sub did each kid get in each of those sort of different locations.
Yeah. If you
Um,
have,
and-
if so, you want them to stop, right? Stop and take some time to
Yeah,
work
pause
through
the
the problem.
podcast. Yeah. Better if you have thought about it a little bit, because what we're gonna do is what we would never want to do in class. We're just gonna now kind of tell you a bunch of stuff. We're
Yeah.
gonna kind of share with you some of the results that happen after you've grappled with those relationships. So we want to give you guys a chance to grapple first, because the learning is better that way. Absolutely, yeah. So there's a ton of cool things that we could talk about with this rich task.
Mhm.
We'll see how many we can get to today in the podcast. Let's see if we can. So go, Kim. Let's go.
Okay. So we worked with this with some third graders, right? Like we're talking
Mhm.
about a specific instance. We've done third graders through adults. So when I went into a third grade class, I launched the problem, I sent the kids off to work, and I expected to see a couple of the challenges that I saw. But there was this one thing that happened that I didn't anticipate with this particular group. And it's that they were struggling to name the pieces. I thought that would be something that they could handle right away. But it was interesting to me because when they cut,
Well, and in fact, because the teacher that you went into, this is not your group of kids,
right,
you went into and you said, tell me what the kids have done with fractions. And she said, oh, we've done everything we need to this year.
yeah,
And
yeah,
so
yeah,
you were really clear that if you'd cut something equally into 3 pieces, kids should be able to call that 1/3.
sure,
Each of the
sure,
pieces 1/3. If you cut it into 9 pieces, kids should be able to call that 1/9. That
Mhm.
should be a beginning 3rd grade task. So you were really clear. So you were a little surprised when there were some students who struggled to name the pieces.
Right. Yeah, yeah. And so, and you alluded to this in an earlier episode. I think maybe it was last week, 2 weeks ago. Sorry. But when they cut a sandwich into halves, they could easily call it 1/2 and 1/2. They could label those 2 pieces. But when they got one of those halves and they had to cut it in half again to make 2 1/4, so they had 1/2 and then they had the other half cut into half to make 2 1/4. They now wanted to call those pieces 1/3 and 1/3 because they had 3 pieces. So in reality, they had half a sandwich and a fourth and a fourth, but they were calling those those 3 pieces equally 1/3. They're calling it half of a sandwich and a third of a sandwich and a third of a sandwich.
Yeah, because they sort of saw 3 pieces. And so their
Yeah.
kind of limited understanding was if I see 3 pieces,
Right.
regardless of the fact that they're not the same size,
Yeah.
then I'm going to call them 1/3.
Right.
Yeah, cool. So notice the numbers in the problem that we gave you a minute ago and how nicely they're chosen. When I was watching the video of you doing this with these 3rd grade kids, you said, what are you guys thinking? Was it fair? And a couple kids were like, I don't think it's fair. I think it's fair. They didn't really have a lot of reasons. And you called on one kid, I'll never forget. He goes, well, it's not fair because there's a 5 and a 5 and a 4 and a 4 and a 3 and a
Mhm.
5 and a 4. And I was like, and you even said, whoa, like your eyes got kind of big. I knew that you followed what he did, but you were also really clear that the rest of the class did not, right? The
Yeah.
rest of the class was like, what just happened here? Because he literally was sort of pulling some of those numbers out. So let me slow down a little bit. There's a 5 and a 5 and a 4 and a 4 and a 3 and a 5 and a 4 and a 5. What was he talking about? So one of the things that this wonderful young man was talking about was he was comparing the same number of kids getting different amounts of or different numbers of sub sandwiches.
Yeah.
So for example, in the problem, 5 kids sharing 4 sub sandwiches went one place and 5 kids sharing 3 sandwiches went a different place. And so he was really clear, 5 and a 5 and a 4 and 3. Like that doesn't, what he means is if 5 kids are sharing 4 sandwiches, they're going to get more than 5 kids sharing 3 sandwiches. Like it's the same number of kids sharing more sandwiches, they get
Mhm.
more.
Mhm.
Same number of kids sharing less sandwiches, they get less. So he was clear on that right away that it wasn't fair. So that's an example of same denominator because we could think about 4 subs shared among 5 kids. That's like 4 subs to 5 kids. So 4/5 of a sub per kid and 3 subs shared among 5 kids. That's like 3/5 of a sub per kid. So you're sort of comparing 4/5 to 3/5. That's like same denominator, but totally thinking about it in context about how I could reason about which one was greater. And context helps the
Yeah.
students reason. It's a great example.
Yeah, and so you can also compare, and I think one of the other things he pulled out was when the number of the subs is the same. So there was a group
Mhm.
that had 3 subs shared by 4 kids, or there were 3 subs shared by 5 kids, and comparing 3/4 of a sub per kid and 3/5 of a sub per kid, since the numerator was the same, you can compare the denominators. And really, the context makes it so nice because more kids sharing means that you're going to get less per kid.
More kids sharing the same number of
Right.
sandwiches means that you get less. Yeah,
Yeah.
totally cool. So then in the scenario, the kids get to work, or
Yeah, in my group.
in your group, the kids get to work and they're splitting up the sandwiches because you actually say to them to determine if it's fair, figure out how much of a sandwich each kid gets in each, how much of a sandwich each kid gets in each group, right?
Yep.
So one of the strategies that we consistently see, whether we do this with 3rd grade kids or 4th or 5th or adults, we see this strategy that I think is kind of the smart volunteer strategy. Like the volunteer that went with the kids is cutting up the sandwiches, and it's to start by cutting sandwiches in half. And
Mhm.
so they create halves and they give everybody a half of a sandwich, and then they're left with some pieces and they cut those up.
Mhm.
So, for example, If I'm in the scenario where I've got I got to think for a second, where I've got 3 subs shared with 4 kids, then I'm going to take those 3 subs and I'm going to cut the first one in half, and you get a half and you get a half. And now the second one in half, and you get a half and you get a half. Now,
Right.
each of the 4 kids have a half.
Right.
And I've gotten rid of 2 of the subs out of the 3 subs.
Yep.
But now I have a sub sandwich left. What do I do to split those up? And so this is kind of the general idea where they get rid of the halves and then they deal out the leftovers. So one of the strategies to compare who got more, which group did, they determine it's not fair. And so then you're deciding which group got more, is to just sort of kind of do what they did as they were dealing out. Well, if everybody got a half of a sandwich and then we divvied up the leftovers, each group that happened, then we can just like ignore the halves and just compare the leftovers. So for example, one of the groups gets a half of a sub sandwich plus a fourth of a sub sandwich. That's the group actually I was just talking about, the 3 subs shared among 4 kids, because after you've split out the halves, you're left with one sub sandwich left to split among 4 kids. Then they each get a fourth. And to save time, I'll just say that in one other group, each of the kids gets a half plus a fifth of a sandwich. So you have these 2 groups where each student in each group got, in the one group, they got a half plus a fourth of a sandwich. And in the other group, they got a half plus a fifth of a sandwich. Well, now you just can end up comparing a fourth of a sandwich to a fifth of a sandwich.
Right.
So important, where now we're comparing unit fractions. And so since all of these are unit fractions, where we're giving each kid a fair share of the next piece to cut up, kids are really sort of ingraining this idea of what unit fractions are and how to compare those unit fractions. So great outcome for that strategy.
Yeah. And so in another scenario, you just talked about dealing out half first.
Mm-hmm.
There's another strategy that a lot of kids do, and the students would cut each sandwich into all of the pieces. So in the group where 4 kids are sharing 3 subs per 4 kids, each sub gets cut into 4 pieces and they deal them out. So they cut the first sub into fourths, and you get a fourth, you get a fourth, you get a fourth, and the last kid gets a fourth. And they keep doing that with each sandwich, and all the kids have these tiny pieces. And then they count the number of pieces that each kid got. Since they cut up 3 sandwiches, each kid got 3 1/4s, 3 of those 1/4 pieces. So like 1/4 from each sandwich, or 3/4 of a sub per kid. Because when you put those 3 1/4s together, like smush them into a sandwich, that's 3/4 of a sandwich.
Totally cool. And so this is the strategy that I think is not maybe what a real volunteer would do as they're trying to cut up, right? Because now you have all these little tiny pieces. Can you picture that if I cut up every sandwich into those fourths, and like you said, each kid gets a fourth, somebody's going to get the end every time. Some sandwich, right? And so you got one kid that gets 3 1/4, but they get the heel every time. It's not very nice. I don't know. But it is actually a very typical strategy, because it's sort of easier for kids to go, well, if I got 4 kids, I'm just going to take each sandwich and divide it evenly. And now the next sandwich and divide it evenly. That's kind of a way to think about that. So interestingly, the kids in my scenario cut unit fractions, but they're all different size unit fractions, because they were looking at different wholes, different units. They started with a whole sandwich and cut as many as they could into equal halves. But then they cut those halves into pieces, which means the unit shifted. Now, as I cut that half into halves, I divide a half into 2 pieces. Now I'm thinking about what's half of a half. And so that's the unit shifting. It's what's the whole. That's really interesting. We're reunitizing. It's one of the things that makes fractions so hard, is that we have to be really careful about what the whole is. But Kim, in your scenario, kids were cutting each sandwich into the same size pieces, always from one whole sub. Their unit never shifted, right? So it was always, I'm going to take this whole sub and cut it into all these little unit fractions.
Yeah.
Either way, a super great beginning way to mess with fractions. Notice that both are all about unit fractions, where the numerator is 1.
Yeah. So how do kids compare in that scenario? Since they've been cutting those tiny pieces, fourths in the group that shared among 4 kids, and fifths in the group that had 5 kids, and eighths in the group that had 8 kids, they're really clear on the size of those tiny unit fractions, the tiny pieces of sandwiches. So now when they compare, sometimes a really cool strategy comes out. What's really cool is that they can compare the amount of subs by thinking about how much a student didn't get.
I love this strategy.
Yeah,
so
if a
cool.
kid got 4/5 of a sub, they didn't get 1/5 of a sub. And if a kid got 7/8 of a sub, they didn't get 1/8 of a sub. And they can still use unit fractions to compare. They can consider how much to the next whole sub.
Oh, that's so important. So
Yeah.
I can think about how 3/4 of a sub compares to 4/5 of a sub
Mhm.
compares to that 7/8 of a sub. And those were numbers from the problem because they look like often kids will look at it and go, I don't know, like they're all close to the whole sub.
Yep.
But how close are they?
Yeah.
Oh, they're just a unit fraction away. So they could use what they know about the size of those unit fractions to help them think about the whole fraction. So cool. So many important things happen when we focus on a well-written, purposefully planned, rich task. In this case, sharing fairly. Students get a chance to develop unit fractions and get a great sense for their size and also what happens when you combine them, that 3/1/4 is 3/4. Students get a chance to reunitize what is a fifth of a half of a sandwich. Students get to start developing the strategy of comparing fractions by looking at how far the fraction is from the whole, how far the fraction is from the whole by looking at the unit fraction. So many cool and important notions about fractions. Then, y'all, after I do a rich task like this with students, I'd want to do a problem string to help solidify some little part of that. So cool. Stay tuned because we are going to continue to talk about how to build fraction sense in our students and even get to some fraction operations coming up. I'm so excited.
Yep.
So y'all remember to join us on Math Strat Chat on Facebook, Twitter, Instagram on Wednesday eves, where we explore problems with the world.
Hey, if you find the podcast helpful, would you please rate it and give us a review? That way more people can find it wherever they get podcasts.
Yeah, and don't forget that we're collecting your questions that you want answered. Send those to Kim at mathisfigureoutable.com. Kim, do you like how we're sending them to you?
Yeah, I love it. Love it.
Because Kim will keep them and keep them
Won't lose
organized.
them.
Yeah, she won't lose them. She'll keep them organized. And we'll tackle those questions in an upcoming episode coming soon. So send those in soon so we can make that happen. So if you're interested to learn more mathematics and you want to help yourself and your students develop as mathematicians, then don't miss the Math is Figureoutable podcast because math is figureoutable.